right. Well, we're ready to get started here. And the great thing about the TechCrunch is all these other panels will often use the term moonshot. Well, this is literally the discussion that's about moonshot. In fact, the title of this one is Cislunar, the Next Frontier. So for those of you who are not space cadets, you're probably saying, what the heck is Cislunar? Well, Cislunar is the distance from Earth to slightly beyond the moon. So normally our satellites go out to an orbit that's maybe 20,000 miles, 22,000 miles. We're talking 230,000 miles, or a volume that is literally 1,000 times bigger. So we got a lot of real estate to work with here as we go forward. So with me here today is a good friend, AC Charania, who is the chief technologist at NASA, which I think has got to be one of the coolest jobs. And that's pretty cool.
Pretty cool.
And I know AC from earlier in his career. In fact, he's probably unique in this job, having come from startups. He was at Blue Origin, leading a lot of their lunar strategy going forward. And we had a chance to work together when we were at Virgin Galactic, and you've been at other startups. So, AC, welcome.
Thank you, Steve. Yeah, it's a pleasure to be here at TechCrunch and to talk about our return to the moon with all of you and all of us and our international partners in commercial industry. So I think it's an exciting time, and I think we have a good conversation planned for all of you. And also how you all can be engaged with our return to the moon, both our nation and internationally. And I'm pretty excited about the way we're going back. So, yeah.
So I'm going to ask a quick poll out in the audience here. So the last time we had humans stepping on the moon was 1972. How many of you were around to remember that? Yeah, not too many hands go up. Well, we are headed back to the moon this time. Now, here's another question. How many of you would like to walk on the moon if you had the opportunity to go there? Hands up. All right, I counted 63% of the audience raised their hand. So for me, a lot of my inspiration actually came from a movie. A movie it's a classic called 2001: A Space Odyssey, made in the 1960s, whose special effects are as good as anything that there is today. And there is a sequence in the movie where they show a vehicle that was able to transport anybody who wanted to go to the moon using what was the big airlines of that day, which was Pan Am. And first of all, that's a very cool-looking spaceship. Start off with that. But I, as a little kid, got completely enamored with the idea of sort of commercial activity extending beyond Earth all the way to the moon. And by the way, it's also a great movie because there is the HAL 9000, which I would argue is the first movie about artificial intelligence. Open the pod bay door. So what I wanted to talk with AC about is really three overarching questions. We went to the moon last time, and we left, and we haven't been back there in over 50 years. So what's different now as NASA undertakes the Artemis project? Number two, what commercial activities are there that are out there? And then three, what is some of the exciting tech that's out there, particularly as the technologist? So let's start for the first one, AC. So why is it different today from what we had done in the 60s and 70s?
Yeah, I think that's a good question, Steve. And I think it's a multiple set of answers. One of the answers is the strategy at the agency, at NASA, that we have of going back. That strategy includes not only going back to the moon, having longer surface stays, maturing technologies, developing a lunar space station, but getting the experience to help us then achieve a human exploration mission to Mars and to the rest of the solar system. So there's like kind of over the last few years, the agency at NASA, we have worked to develop a strategy step by step that starts with human lunar return, the first few missions in the program we call Artemis. So that's one differentiator. Another differentiator is the world has changed. Mm-hmm. There are now commercial companies, international states that have a lot more capabilities than they used to. Small teams and medium-sized teams of the 21st century have capabilities that were not imagined in the 20th century. And that includes allied nations such as India, Canada, the European Union, UK, the United Kingdom, Japan, South Korea, that are all interested in sending assets to cislunar space, to the lunar surface, developing lunar rovers. And finally, I think it is also the commercial industry that we've seen emerge over the last 20 years. And the innovation and the technologies that they have brought to bear, and the funding and public-private partnerships. The way we're going back to the moon has traditional NASA programs that a lot of our industry and people who went back to the moon, or who went to the moon in the 1960s would find similar. But then there's pieces of our architecture that would stretch the imaginations of the leadership at NASA even 25 years ago. So for instance, we talk about crewed lunar landers, the landers that will rendezvous in lunar orbit with the astronauts and bring them down to the surface for an initial 6.5-day surface stay and bring them back up. Those are being developed by SpaceX and Blue Origin. Now, and they're not only being developed by commercial space companies, the technologies those companies are going to be using leverage propellant depot-based architectures, basically gas stations in space. So SpaceX and Blue are going to develop an architecture that has gas stations in space to refuel the lunar landers, and that will be the lunar landers we will use at NASA to send our astronauts down and to bring them back up from the lunar surface. And those are being developed with contributions from those companies that are equal or more to what NASA is providing them in contracts, and leveraging fixed price milestone-based contracts. And those are single-stage landers. In Apollo, we had 2-stage landers, a descent stage and an ascent stage. So these commercial companies have provided proposals, and we've accepted them, that leverage advanced gas stations and space technologies, single-stage landers using fixed-price contracts, leveraging public-private partnerships, leveraging their own funding that they're bringing to bear. And so those qualities of how we're dealing with commercial space, the tremendous interest with a whole series of international states around the planet interested in going back to the moon, and the technologies that we're bringing to bear to enable sustained lunar presence, mature technologies on the surface of the moon that we can use then to go on the way to Mars with humans and robots, kind of all make this a little bit different. And each of those individually don't make this Artemis program, to me, different, but all those combinations of things now make it more sustained, more interested. An example of this is we have, over the last few years, signed a series of agreements with 47 nations we call the Artemis Accords, which talk about the principles of going back in terms of how we deal with debris, how we deal with deconfliction, how we deal with notifying each other of our missions, notifying each other of how to rescue astronauts in terms of each other's programs. And the tremendous interest in getting 47 nations to sign this set of accords, actually named after the Kittimer Accords in Star Trek, if those of you that know your Star Trek references, I think shows the tremendous global interest in companies and states and countries for going back to the moon. So,
yeah, so you gave 3 powerful reasons. I mean, first of all, commitment through NASA. Second, international. Third is the commercial activity. And one I'd add is just, I think you're alluding to, is the tech. Yeah. You know, it used to be true rocket science to be able to put satellites up, and as we've heard from previous speakers today, it's no longer just superpowers that are doing this. As startups, with a few $1 million can actually put things in space. One of the most audacious things that I find that NASA is doing right now is actually having a commercial lander program. Right. So I want to put up a slide that you gave me, AC, to talk about commercial and other attempts to land on the moon.
Yeah, these are not renders. These are not AI-generated images. These are real images of 4 global lander programs. 2 of these are American, the left-hand side from Intuitive Machines and Astrobotic, and 2 from our international partners, the upper right from the Indian Space Agency and the lower right from the Japanese Space Agency. And these are our initial attempts to land on the lunar surface. And what's actually pretty cool is in the Intuitive Machines landing is the first successful commercial lunar lander in history. And that was enabled by a public-private partnership with NASA. Many years ago, NASA decided and saw that there was a momentum of interest in developing spacecraft and lunar landers. And we helped encourage this program to provide services and contracts to these commercial United States providers for small, medium, and large landers. So we have allocated, to my account, more than $7 to $8 billion amongst several companies, small, medium, and large, to develop these lunar landers. And our first shots on goal are the two images you see here, and we've got more coming as well over the next few years on these smaller landers, plus working with Blue Origin and SpaceX on much larger landers that can land, instead of tens of kilograms or several hundred kilograms, can land 20 metric tons, 30 metric tons, 100 metric tons, once again in public-private partnership. And so I'm pretty excited about all the assets in cislunar space, both on the surface, around the moon, and this includes both landers, but also the payloads, the science payloads. But as we try to get science and we try to work with commercial industry, we also need services. So all these landers, all this infrastructure needs power, communications, position, navigation, timing, and a whole bunch of other services to enable this future that we're talking about. So.
Yeah, so that's a very exciting future, and I particularly like this next picture that's just a moon view, looking back at the Earth, an incredible shot. So of those commercial activities that you mentioned, are there any in particular, AC, that really stand out for you, saying, all right, these are ones that I could see business cases that would close?
I think what I think about is we're making tremendous investments in the crewed and cargo lunar landers I mentioned with SpaceX and Blue Origin, the Human Landing System program, as we call it. This will be the landers that will land humans and large payloads on the lunar surface. And what I think about is the expansive effect of these technologies. Once again, gas stations in space, these two companies are building that infrastructure. And what else can companies do leveraging that infrastructure to explore other parts of the solar system, to enable other businesses? And once again, as I tell people, as you think about your business, how are you leveraging the investments we're making with small lunar landers, medium-sized lunar landers, large lunar landers, these large capabilities, lunar mobility? We're also investing in lunar surface rovers for both astronauts and those that can operate autonomously. What kind of technologies, infrastructure can you add to these existing systems? The other thing I would tell you as you approach NASA about working with us is think about the mission. There's tech development we want to do and tech demonstrations, but ultimately it's about our NASA missions. The NASA mission to land humans on the moon, to sustain their presence, to get experience, to go onwards to Mars. And so how can the technologies and services you provide enable us to stay longer, do more, get more science, get more data back, process more data on the surface, and explore more of the moon, explore more of cislunar space on the way to other destinations in the solar system. And the other thing I would say I think about is the initial missions to land humans on the moon. In our Artemis program, we called Human Lunar Return. The later segments talk about expanding capabilities, developing infrastructure, providing reservices to that infrastructure, and going from 6.5 days to 30 days surface day to longer. But ultimately, I think about the lunar moment, and this is a much larger philosophical kind of vision for this 21st century. Is there's a moment in this century when a human walks on the moon, and from then on, there will always be a human on the moon. We at NASA like to say that there's an International Space Station orbiting above us for more than 20 plus years, and there are children born today that have always known a space station. The analogy I use and what I'm trying to focus on are technologies, infrastructure, services to enable the moment, that lunar moment, to enable children to be born in this century who will always know a person that's on the moon. And in that sense, their vision of technology, their vision of access to the rest of the solar system will be inspired by this lunar permanent vision, the sustained lunar presence that can be enabled by nuclear surface reactors, optical communications, various technologies to enable this lunar infrastructure to emerge, get more science. And so I'm really curious about the technologies that will help us not only get and achieve a safe 6.5 day surface day, but enhance that to 30 days and even longer on the lunar surface, and then attempt the human mission to Mars.
So you mentioned technologies. You're the chief technologist.
Right.
Are there 2 or 3 technologies in particular that you're excited about? Like this would be breakthrough, game-changing kind of stuff.
I'm pretty excited about our optical communications investments. We have demoed and tested high bandwidth communications on the International Space Station that have multiple gigabit per second kind of capabilities to return data. That includes demonstrations on the Psyche mission, which is an asteroid mission. We're putting an optical comm payload on the Artemis 2 mission that's going to send 4 astronauts around the moon. And so as I think about services, if we provide high bandwidth communications, precise position navigation timing services, people will use that. If we provide power, people use that. That's not a bad thing. Giving us and our astronauts and our crews more bandwidth, more power is goodness. And we will find a way to use it. It's kind of like, an analogy I'll use with Steve is, I work for Steve, and when we were at Virgin Galactic, Steve found a pretty big building in Long Beach. And we were wondering, are we really going to use this big building? And Steve wondered that. And when we got the engineers there, we were only going to use half the building. But as soon as we moved in, we started looking at that space and expanding into it. And it's the same analogy I use for Cislunar comms, PNT, power, and other services. We provide it to our communities. They will find uses for it. And so I think about it that way. What are the technologies and capabilities that will enable this expanse of exploration? And I think those, to me, are the most exciting. And optical communications is something we've invested in. Now it's the question of how do we apply it to the mission? And so that's one thing. And then the other thing that excites me is probably surface Wi-Fi. So one part of NASA has been investing with Nokia US on a lunar surface Wi-Fi network, and we're now looking to use that for our Artemis mission. So once again, that comms capability that we've invested in, how can we use that to enable better surface exploration for our astronauts? So these kinds of comms, PNT technologies are exciting to me.
Those are great, although I thought you were going to say mining for lunar resources.
But even that will need comm and PNT and power.
The secret program you have working on a transporter and photon torpedoes. But you got to have some imagination.
All right, we'll give you a contract to help us study that. How about that, Steve?
You're on, and we're working on it. All right, so as we wrap up here, AC, I'm going to do a quick lightning round with you, so sort of bang bang with the couple minutes we have left. So how many people do you predict will actually be working on the moon in the year 2040, and what percent will be from the U.S.?
I'm tempted to say 42, but I'm not going to say that. I'll say 10. People know what I'm referring to there. All right, I think a good goal is double digits.
And what percent U.S.?
More than half.
More than half.
Yeah.
All right. What are you most excited about in humans on Mars?
I think the long-term exploration potential of the red planet, and also seeing how the technology investments on the moon helped enable Mars, right? That investment to cislunar space paid dividends directly to enabling Mars surface architectures. Yeah.
If you could wave a magic wand and solve one really hard technical problem, what would be that technical problem?
Probably, I think landing pads on the lunar surface. These are pretty large landers, and we want to operate responsibly and sustainably on the lunar surface. And landing pads, to me, are the first step to this larger infrastructure that we're talking about. It's not lunar bases, but before you get that, you need rate, you need access, and landing pads, I think, are part of that that solution.
See, and I thought you were going to say a dust buster, because you might not realize the moon is unbelievably dusty. Right. It's going to be a big challenge once we get there. What one piece of advice would you give to someone looking to build a space business?
You don't have to reinvent everything. You don't have to create everything. Leverage the services and capabilities that are out there, and how can you build on top of that? Build on top of, the internet, let's say. You don't have to, in terms of the internet analogy, you don't have to build a payment system. You don't have to build TCP/IP anymore. You don't have to build a browser. Build your business assuming those things might exist, and then what could you do? And then how do you scale that very rapidly to get costs down? And then finally, if you're thinking about things, reusability, right? A lot of people are using that as a mechanism to enable all these things to get costs down and access up.
Okay, last question. If you're the next person to step on the moon, what would be your immortal words as you put that first footprint down?
I don't know. Yeah, that's a good question. I think probably the future favors the bold. Let's go boldly.
Okay.
Yeah.
I'd probably just yell out, "We're back." AC, I want to thank you. It's a great conversation, and this is a really exciting area, and I'm really excited about the work that you're doing now and well into the future. So thank you.
Us and all of you as well. I'm pretty excited. Together, we're going to get back to the moon and onwards to the rest of the solar system. So it's a great time.
Okay.
Come help us.
Thank you, everybody.
Okay.
Good job.